Good morning, everyone. What I want to do is review some formula writing, which we learned last class when we did nuts and bolts, and then we're going to transition into balancing equations. So we need to understand what a formula tells us in order to be able to balance equations, which is an essential skill for chemists to do. Okay, so here's a formula. This is AlCl3. Okay, once you become a little more familiar with formulas and whatnot, we're not going to think that these are I's or anything like that. They're just lowercase L's. All right, so we got AlCl3. So what we want to know from this formula itself is that this 3 only applies to the Cl's. Okay, and when we start to be able to write chemical formulas using ions, it'll make a little more sense. But from what we know from nuts and bolts, that this 3 only goes with the Cl. So sort of in the picture, what we have is that there's an Al, and there's one Al, and there's 3 Cl. So this is sort of a nuts and bolts picture of what we see there. Okay. What we should also be able to do is say that, okay, there's one Al, and then we can list out how many Cl's that we have. Cl, Cl, Cl. So what we want to be able to take away from this formula is that this 3 only applies to the Cl and not the A. It does not distribute. Now the next example here does distribute because we have parentheses. So this is going to rely on a little bit of your background in math. You've got Ca3, and then we have parentheses PO42. Now what we're going to learn from here, this 3 says that there's 3 calciums. So I'm going to write Ca, Ca, Ca. And then this 2 distributes. So because there's no number here, we assume that there's 1 P. So this is going to be 2 times the P's and 2 times the 4 O's, which would be 8 O's. Another way to sort of think about that is if I were to write this out. The parentheses essentially mean that I have 2 of whatever's inside. So without the parentheses, I have 1 P and 4 O's. That's what I'm going to write. P-O-O-O-O, and then P-O-O-O-O. All right? And if you say that out loud, it's kind of funny. Ka-ka-ka, poo-poo. All right? The reason we kind of write that out is so we can illustrate how the distributive property works and how it backs it up. So again, we have 2 of whatever's inside. Here's a PO4, and here's a PO4. So if you count them up, there's going to be 2 P's. Again, when we distribute 2 times the 1 P is 2. And then there's 4 plus 4, there's 8 O's, and 2 times 4 would be 8. We want to know that there's 3 CAs, we want to know that there's 2 P's, and there's 8, I'm going to say O's. All right? That's what we want to know. And that's going to help us understand balancing equations. Balancing equations rely on the law of conservation of matter, which says that matter cannot be created or destroyed, it just changes form. All right? So here's an idea behind that. So let's say we take some sodium and we mix some chlorine with it. 2 very dangerous chemicals. Sodium explodes with water, and Cl, the chlorine gas, if you breathe it, you die. But if you mix them in the right ratio, you will make NaCl, which is table salt. Now, as we look at this, what I'm going to do is I'm going to keep track of how many of each of our elements we have. So I'm going to list individually all the elements that we have here. And we've got Na, and then we've got Cl's. And then I'm going to start out by listing how many we have of each before we do any balancing. So right now, there's no number in front here. Just put a blank there because we might fill in a number. There's 1 Na on this side, and there's 2 Cl's on this side. Over here on the right-hand side, this is our product side, you've got 1 Na and you've got 1 Cl. So as the equation is written, this we call a skeleton equation. As it's written, it looks like in this reaction that we lose 1 Cl. We start out with 2 and only end up with 1. And that's not possible. So what we can do is we can always add a number in front called a coefficient to be able to try to balance things out. So because the sodiums are balanced, I'm going to put a 2 in front of the of this. I'm going to put a 2 in front. It's going to help me kind of balance things out. It's almost like a teeter-totter. So you add things to one side so that it balances the other side. So now having a 2 in front, this says I have 2 of these. So I have 2 NaCl's. And this does distribute. So now you not only have the 2 Cl's, 2 times the 1 Cl gives me 2 Cl's, but I also have 2 Nas. So by fixing sort of and balancing out the Cl's, we've messed up the Nas. So we're going to go back to the left-hand side and we're going to put a 2 in front. So 2 times the 1 Na gives me 2 Nas. And we can see now that everything is balanced and my equation is balanced. You don't have to put a 1 here. You can. If you're working on the computer, you do want to have a 1 here because computers don't like empty spaces. So some of the online activities that you're going to do, you're going to need to put 1s in there if you're online. Okay, but that's how you balance equations. Here's another example. All right, it's going to be Al2O3 plus HCl goes to AlCl3 plus H2O. All right, we start out over the arrow and we write down all the elements that we have. You have Al, you have O's, you have H, and you have Cl's. And I'm only looking on the one side because I know that you're going to have the same elements on each side. So I'm going to start out by listing out how many we have of each. We have 2 Al's, you have 3 O's, you have 1 H, and you have 1 Cl. On the right-hand side, I'll do the same thing. Be careful of putting things in the right spot. 2 H's and 1 O. Now, one thing I forgot to mention is a little bit of a hint that will help you. You want to tend to balance your O's and H's last if you can. And that should help you in terms of balancing your equations. It just seems like the O's and the H's fix themselves if we balance them last. So I could either balance my Cl's or I could balance my Al's because they both don't match here. So I'm going to go 2 Al's because it's just first. So I'm going to put a 2 in front there. Now this makes distributes 2 Al's, but now I have 2 times the 3 Cl's, which makes a total of 6. So when you put a number in front, it can sometimes affect more than one element. So now my Al's are balanced, O's and H's last. I'm going to go to Cl's. So I have 6 on the right, so in order to fix that, I'm going to put a 6 in front. So 6 times my 1 Cl gives me 6, but now it also affects my H's, so 6 times my 1 H gives me 6. So in balancing my Cl's, again, I change the H's, change another one. Al's are balanced, Cl's are balanced. Now I'm going to work on fixing the O's or the H's. It turns out it wouldn't matter which one I do because the O's and the H's on the right-hand side are together. So if I want to say how many, what number would I put in front so that I end up having 3 O's, it's going to be the number 3. Because 3 times my 1 oxygen gives me 3, and 3 times my 2 H's gives me 6. So we can see that everything is balanced in this equation. All right, 2 and 2, 3 and 3, 6 and 6, 6 and 6. Again, you can put a 1 in front here if you want. Online, you do definitely want to do that, but in practice, in the textbook or things like that, you would see it blank. All right. And we got one last one I want to show you, and then it's going to be kind of on your own a little bit. And so, leave that up here a little bit. And the last one is we're going to have P2O5. All right, that's all together. Just kind of wrote it far apart. Plus BAO goes to BA3 parentheses PO4 2. Okay. So we've got that. And what's tricky right away, something I notice, I have O's in two different spots. So when you keep track of them, you definitely want to be aware of that. Okay, so I'm going to list out P's, O's, and BA's here. I also chose this example because we've got a polyatomic ion over here. In other words, we have these parentheses. Okay, so we're going to list out how many we have. The O's, we have 5 plus 1, so we have 6. And we have 1 BA. On the right, we have 3 BAs, 2 P's, and 8 O's. All right. So O's and H's last. The P's are already balanced, so we should balance the BAs next, right? So I'm going to put a 3 in front here, and so I got 3 here. And now we also affected the BAs, and now we also affected the O's. So 3 times my 1 oxygen gives me 3. 3 plus the other 5 gives me 8. Look at that. So in this problem, it was actually fairly straightforward. But the trick here, and the thing we wanted to remember, is that when you have elements in different spots, you always have to be really careful about adding up the total. Notice I didn't just add 3 oxygens to this, making it 9, because it was 3 times the 1 plus, so 3 plus the 5 gives me 8. All right, and again, we could put 1s on here if I'm doing this online. Another little tip and hint, besides the O's and H's, we'll come up with some faster ways of doing this later on, is that if you're spending more than, say, 5 minutes, trying to work out a problem, chances are you made a simple error in the beginning, which has prevented you from balancing it. Okay? Hope that was helpful. Take care.